Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone is doing all right out there. This is for Unit 5, Lesson 3. Let's go ahead and jump into our goals. We have two goals today. Our first goal is to define the transitive property, and our second goal is to use the transitive property to solve linear systems. So I'd like to start off the first goal with an example, and I think that this is something that most everybody at your age understands, and it's a very mathematical concept, but you already know what the transitive property is. So let me explain how you know it. So $20 is the same as two $10 bills. $20 is also the same as four $5 bills. So here I have two things equaling to the same thing, and so we can logically conclude that these two things themselves must also be equal. We know that two $10 bills is the same as four $5 bills. We know that. They're both 20 bucks. But you can actually look at this as through the lenses of the transitive property and realize you already know the main idea for the lesson. So again, if two things are equal to the same thing, those two things themselves must be equal. Okay, so hopefully that makes sense. Now here's how it's written mathematically. The transitive property. If A is equal to C and B is equal to C, I have two things equaling to the same thing. Therefore, I can conclude those two things themselves must also be equal. The transitive property is really a way to bring equations together. I can bring two equations together. So again, if two things are equal to the same thing, then those two things are equal. If two things are equal to the same thing, then the two things are equal. If two things are equal to the same thing, then those two things are equal. If two things are equal to the same thing, then those two things are equal. You know how to set this up. You know this property. So I'm going to check off the first goal here before I jump into the second goal. I'm a little rusty with my transitions in the lesson. I haven't filmed one in all year, so a little off. The second goal is to use a transitive property to solve linear systems. We were solving these by graphing, right? You put them on decimals, you find out where they cross, you get your answer. This is going to get you the same answer. It's just another way to do it. This is the algebraic method. Now, I listed out the steps that I'd like you to do. First step, use a transitive property. Again, we have a bunch of things equal to the same thing, and we can now set them equal. The second thing is we're going to use our 6 steps to solve an equation. Eliminate fractions, distribute, combine like terms, get all variables to one side, add or subtract a weighted number from the variable side, and divide a weighted number. The third thing we're going to do is we're going to use the x value from the second step to find the y value. Use it in either equation. Whatever equation looks easier to use it. And finally, just a tip, if you have a negative with a fraction, put it with the numerator. That'll make things a little bit easier for you. So let's just go ahead and jump right into our second goal and solve these things. So again, now I have these problems are very specific. No fractions, one fraction, two fractions. And the homework's broken up like this. So the first two problems, there's no fraction. The next two problems, there's one fraction. And then the last two problems, there's two fractions. All right, so I'm going to use a transitive property because both of these are equal to y, so I can conclude that they themselves must be equal. Minus 4x plus 3 is going to be equal to x minus 2. Now I'm going to put a 1 in front of there. 1x minus 2. And I'm going to write down my 6 steps. 1, 2, 3, 4, 5, and 6. All right. Can I eliminate a fraction? No. Can I distribute? No. Can I combine on each side of the equal sign? Can I combine like terms? No and no. Can I get all variables to one side? Yes. I'm going to move the 1x to the other side, and we do that by subtracting, right? The opposite. All right. So this side it cancels, and now I owe 4, I owe 1 more, so that means I owe 5. Minus 5x plus 3, that just comes down, equals to minus 2. Step 5 is add or subtract away a number from the variable side of the equation. This is a number I'm going to have to subtract to the other side. So minus 3 to both sides. And we get minus 5x equals, I owe 2, I owe 3, I owe 5. And my last step is to divide. So I'm going to divide everybody by this negative 5. Make sure you don't lose that negative sign. Negative 5 goes into negative 5, positive 1 time. So I've solved using my 6 steps. I got a value for my x. I'm going to use the x value to find the y value. I like this equation because the numbers are nicer. So I'm going to plug this into this equation. I get the same answer in either one I use, but I'm going to use this one. So that means that y is equal to, instead of x, I know that, I'm going to use a 1 now. So 1 minus 2. I have $1, I owe $2. That means that I owe $1. So I now have an x value and a y value, which is an ordered pair. And my ordered pair, where these lines would cross, is at 1 comma negative 1. Okay, so this would be me using the transitive property, using the 6 steps, and then using the x value to find the y value. All right, so that's the first example. We'll do the next example in another color. All right, so again, transitive property. Both of these are equal to y, therefore they both must be equal. So I get 2x plus 3 is equal to 2 over 3, x minus 1. I'm going to write my 6 steps. 1, 2, 3, 4, 5, 6. All right. Can I eliminate a fraction? Yes, I can. And remember, we eliminate fractions by multiplying everybody by the denominator. So I'm going to put a 3 next to every number. And they either multiply or cancel. So you get a 3, you get a 3, you get a 3, and you get a 3. All right. So I'm doing my first step. I can't cancel a fraction, so I get 3 times 2, which gives me 3 times 2x, which gets me 6x. 3 times 3 is going to give me 9. There was no fraction to cancel. This 3 has to cancel that, and I'm left with a 2. And then a 2x minus 1 times 3, that's minus 3. Can I distribute? No. Can I combine like terms on each side of the equal sign? No. Can I get all variables to one side? Yes. I will minus the 2x to both sides. And now I'm left with 4x plus 9, that canceled out, equals to minus 3. Can I add or subtract away a number from the variable side of the equation? Yes, I can subtract 9 to both sides. So minus 9, I now get 4x equals, I owe 3, I owe 9, you're going to tell me I owe you 12. And now I have the last step, which is divide. Divide everybody by 4. And I get x is equal to minus 3. So I've used my 6 steps to solve. Now I need to use my x value in either equation to find my y value. I like that equation. I like that equation because this one has a fraction. I don't want to deal with a fraction. So here we go. I go y equals 2, and I'm going to replace the x with a minus 3, and then I have a plus 3. 2 times minus 3, that's minus 6. Minus 6 plus 3, that's 3. Y equals 3, x equals negative 3. I now know where these two lines cross, and they cross at minus 3, comma 3. All right, so again, each example represents 2 problems on the homework. First problem, no fractions. Second problem, 1 fraction. Last problem, 2 fractions. I will do the last problem in black ink so we can differentiate these, right? I might need a little bit more space, so I'm going to just erase that real quick. Okay, again, transitive property says if two things are equal to the same thing, those two things themselves must be equal. So I get negative 1/2 x minus 4 equals to 3/4 x plus 1. The minus was out in front. Put a negative with the numerator. So I'm going to put this negative up here with the minus 1. Alright, so now I need to write down my 6 steps. 1, 2, 3, 4, 5, 6. 1, 2. Okay. And I have 2 different fractions to get rid of, so I'm going to go through the process twice. I'm going to multiply everybody by 2 first. You get a 2, you get a 2, you get a 2, and you get a 2. Alright, so let's see here. I'm doing the first step. And on the first value, it cancels, so now I'm left with minus 1x. Minus 4 times 2, that's minus 8. They don't cancel, so now I just multiply. So now I'm left with 6/4 x plus 2. 2 times 1 is 2. I still have a fraction, so I'm going to multiply again by the denominator, and hopefully this cancels my fraction. Hopefully it will. Why am I looking for a color I can't find? Alright, there's a blue one on this one. So I'm doing the first step twice. Remember, we can wash, rinse, and repeat. Alright, so I'm going to multiply everyone by 4. Alright, and so let's see what we get here. Now I get minus 4x for these guys. Minus 32 for this. These cancel. So now I have 6x, and then I have plus 8. Can I distribute? No. Can I combine like terms on each side of the equal sign? No. Can I add or subtract? Oh, can I get all variables to one side? Yeah, I'm going to move this 6x over. And you'd be fine if you moved the 4x to the other side. You'd be fine. You were still going to get the same answer. These cancel. I owe you 4. I owe you 6. You're going to tell me I owe you 10. Minus 10x minus 32 equals to 8. I'm going to now add or subtract away a number from the variable side of the equation. I'm going to add 32 to both sides. And now I get minus 10x equals, let's see here, 8 and 32, that gets me to 40. And now I'm going to divide away a number. Check mark. No, I don't know if it was right. Minus 10. Minus 10. And here I get x is equal to a negative into a positive. That's going to become a negative 4. Alright, I am running out of space, and I want to have plenty of space to show you how I'm going to find the y value here. But again, I just solved using my 6 steps. Let me make some room here. Exciting erasing going on. Alright, now the question is going to be, which equation am I going to plug it into? It doesn't matter. Alright, it doesn't matter at all. I like the first one because the numbers are smaller. So I'm going to replace x with a minus 4. Alright, so now I have y equals, remember, we put the negative with the numerator. So y equals minus 1 over 2. And I don't say x anymore, I say minus 4. Minus 4. And then minus 4 again, okay. Alright, so I don't like fractions, so I'm going to multiply everyone by the denominator. There's 2 ways to do this actually. We can multiply everyone by the denominator, or if you've done the problem correctly, what we can do is we can just put these numbers together and you'll see that we're going to get a nice result. So let me just quickly review with you something really quick. If you have 2 fractions, like 2 over 3 and 5 over 4, you multiply fractions straight across. So 2 times 5, that's going to give you 10, and 3 times 4, that's going to give you 12. Alright, when you're multiplying fractions, you multiply them straight across. I can make this into a fraction by putting a 1 under. So I'm going to multiply here straight across. Minus 1 times minus 4, that's positive 4. 2 times 1, that's 2. I know that 2 goes into 4 2 times. So now I'm left with y equals to 2 minus 4. I have 2, I owe 4. That means that y is equal to minus 2. My lines cross at minus 4, minus 2. Minus 2. Alright. I kind of imagine that we're going to have a hard time finding the y value when I have a fraction. Every answer on this homework assignment is going to be a nice number. Okay? Remember, we multiply a fraction straight across. So when you plug it in, make it a fraction, multiply it straight across, it will divide nicely, I promise. If it's not, then we're making a mistake. So again, we define the transitive property, which is something you use, and we can use it to solve systems. And we use math that we did last semester. So this is actually, we didn't really learn anything new. We just put things together that we haven't put together before. So again, I hope everyone's doing all right out there. I'll see you guys later. Have a good day, everyone. Bye-bye.